Related rates. Related rate is where two variables are changing over time and there is a relationship between variables. It also refers to problems where two or more quantities are changing over time and you want to find how the rate of change of one quantity is related to the rate of change of another. Essentially, it's about figuring out how fast something is changing based on how fast something else is changing. This is the step to solve the problem about related rates. First, identify the variable and their relationship. Second, express the rates of change. Third, differentiate with respect to time. Lastly, solve for desired rates. Applied maximum and minimum problem. Applied maximum and minimum problem, it is a vital application of differentiation. It also involves using the concept of maximum and minimum value of a function to solve real-world optimization problem. This problem typically requires you to find the largest or smallest value of a quantity, like maximizing profit, minimizing cost, or finding the most efficient dimension for something. This is step to solve applied maximum and minimum problem. First, understand the problem and identify what you want to optimize. Second, set up an equation for the quantity you're optimizing. Third, use given constraint to relate the variable. Fourth, find the derivative. Lastly, determine the maximum or minimum.
The question for the tutorial 29 is the radius of a semicircle is increasing at the rate of 0.8 cm per second. Calculate the rate of change in the area and the perimeter of the semicircle when the radius is 5 cm. Step 1. You need to calculate the rate of change in the area. The formula for the area of a semicircle depends on the radius. To find how fast the area is changing, we multiply the radius by the rate at which the radius is increasing and include the constant pi. Substituting the given values, where the radius is 5 cm and it's increasing at 0.8 cm per second, we calculate that the area is changing at a rate of 4 pi square cm per second. Step 2. You need to calculate rate of change in the perimeter. The perimeter of a semicircle includes both the curved part and the straight edge. To find how fast the perimeter is changing, we take the rate at which the radius is increasing and multiply it by the constants associated with each part of the perimeter. Substituting the same values for the radius and its rates of change, the rate of change of the perimeter simplifies to 4 times pi plus 2 divided by 5 cm per second. The final result for this question is the area is increasing at a rate of 4 pi square cm per second and the perimeter is increasing at a rate of 4 times pi plus 2 divided by 5 cm per second.
Question for tutorial 42. The volume of the container is given by V equals 1/3 pi with 36 x square subscript x cube in brackets, where the height of the liquid in the container is at cm. A. Determine the value of the x so that the volume of the container is maximum. B. Hence, find the maximum volume of the container. First step for question A is that we have to differentiate our V into dV per dx. We have to only differentiate the numbers in brackets only as they have x in them. So our answer gonna be dV per dx equals to 1/3 pi with 72x, subtract 3x squared in brackets. After that, we have to find our x. So, we have to keep in mind that dv per dx equal to 0 in order to find x. And after that, we have to multiply 1 per 3 pi with 72x and negative 3x squared. After that, we're gonna put this equation into our calculator to find the function. After that, we will have two numbers in brackets, and we're gonna flip them to the other side in order to find our x. So the final also, we're gonna have x equals to 24 and x equal to 0. And keep in mind that we have to find value x if the volume max. So for x that have a higher value is 24. So our final answer is gonna be x equal to 24. For question B, we have to find max volume. So with that, we're gonna take our volume equals to 1 per 3 pi with 36x squared subtract x cubed in brackets. And we're gonna fill the x with 24. Then we're gonna, multiply it. We're gonna subtract it. And we're gonna multiply it also. After finish all the inside the bracket first, then we're gonna multiply the brackets with 1 per 3 pi. And with that, we can have the answer 2304 pi as our final answer for max volume.
In conclusion, solving related rates and optimization problems requires identifying variables, using equations to relate them, differentiating, and analyzing results. Mastering these methods equips you to tackle real-world applications in fields like physics, engineering, and economics.